How you doing? Welcome to Howl's Off-Grid Homestead. Today we're going to talk about our solar system some more. Mostly a little bit of some crazy stuff that I've done, and also talking about what we're doing to upgrade, because we're definitely needing to upgrade. We realize now it's winter time. There's not as much sunshine on a regular basis. We still get a charge with what we currently have. It's just not enough to power even the minimum things that we do have, because we really don't use a lot of power here, but we need more than what we have. And I've done a few things to supplement the solar. Unfortunately, it's not really enough. And what I had to do to supplement right now is not super efficient. More efficient than just running the generator straight out, but not as efficient as a solar panel with good sunshine on it. And definitely it's not as efficient as using the creek with the hydro. I plan on doing that eventually, and there will be a whole video on that once I get around to doing that. But it's going to be very time consuming. I don't want to do the hydro, halfway or cut corners just so that I can get it done quickly, because when I do put that in, I want it to be right. I want it to last, and I want it to provide us with a steady flow of power. Again, it wouldn't be a huge amount of power constantly, but it would be a constant, a lot of time with a little bit of power adds up to a lot of power. So that's the goal with that. Dave, stand by. I promise the hydro is coming, but I'm not going to be doing that right away. What I did do is actually leads into some of the things I plan on using potentially with the hydro. It's sort of a proof of concept, I guess you could say. I ended up buying well, not a long time ago, but several months back when we were working on digging the well, I bought a trash pump, or basically it's a big water pump, and it runs on a little 6 horsepower, 5 horsepower motor. I bought it from Harbor Freight, spent 200 and something dollars on it, and it worked great for what I was doing at the time. I used it, I got my use out of it, and then I put it in a trailer, and it sat there for several months not being used because I didn't need it anymore. But what I ended up doing now is I got a 24 volt alternator. It's for a diesel truck. Some large tractors and things like that use them. 24 volt alternator, self-exciting, one wire alternator that I hooked up. Good friend, well, new friend, good guy, right around the corner. His name's David as well. He's got several old vehicles and parts and things like that, kind of his own personal scrapyard, and he helped me out. We pulled a couple of pulleys off an old scrap motor that he had. They were a good ratio between the two pulleys, and we pulled those off so I could use them on this project. I put a pulley on the motor after I removed the pump portion of that water pump. I put a pulley on that side it's about a 5-inch pulley, I think. I'd have to measure it again to be exact, but it's right around a 5-inch pulley. 5.5, almost 6, I think it was actually. And then on the alternator, I put the 2-inch pulley. Again, this gives me a 2-to-1 ratio, plus or minus a little bit. Obviously, it's not exactly 2-to-1, But the motor, the little 6 horsepower motor that was on the water pump, spins at full throttle 3,600 RPMs. The alternator, to get maximum power and maximum juice out of that thing, should be spinning at around 6,000 RPMs. That's like the high side of it. With that, I'm able to spin that motor at 6,000 RPMs and get full power. And basically, I just wired that directly to my batteries. I tried initially going through the charge controller that we had here. I disconnected the solar panels that we have. I didn't want it backfeeding, causing some kind of stuff. I don't have any diodes that prevent backfeeding into those solar panels. So if I have a different power source connected in line, like together with them, it could potentially backfeed to the solar panels and cause problems. And I didn't want to do that. So I disconnected the solar panels from the charge controller, and I connected those positive and negative leads straight from the alternator, and it charged fairly decent amount of charge, not a huge amount, but what we'd be getting right now on a partly cloudy day is about what that was presenting it with, which is actually a good amount for what it is, although it's not going to fully charge those batteries very quickly. The next thing I did after I did it that way to see how well it would go and I could monitor the actual volts and amps that were coming through that, I was kind of thinking that the charge controller may not have been maximizing the charge from the alternator. So I connected the alternator leads directly to the positive and negative for the battery bank. And I kept the solar panels connected to the charge controller. So now what's happening is it's getting a charge from the solar panels, and simultaneously, when I crank up that alternator, it's getting a charge from the alternator as well. And as long as it's going, and this is my understanding, I'm not an expert by any means. I am learning as I go. I do understand basic electricity and electronic stuff. So my understanding is I can have as many chargers or sources connected directly to the batteries as I want. The risk obviously comes into, depending on the type of battery, overcharging it or potentially charging it too fast could damage your battery bank. My battery bank has a built-in BMS, which is a battery management system. And with a built-in BMS, my understanding on that, also looking at the specs, it has a 100 amp limit. So I could pump 29.2 volts at 100 amps into that battery bank, and it will suck up all that juice. That's why I love these Life PO4 batteries. Lithium iron phosphate is the chemistry on those. And it is able to just suck up some juice. Like if I overload it, I have to really be doing a lot, something big. It's got to be a lot. So 24 volts, 400 amp hours, takes a lot to charge, to fill, right? To fill that tank, basically. And so I had the alternator directly connected to the batteries, and it was at the alternator 27.7, around that is what it was pushing out, when the batteries were at 25 volts, which is perfect because my understanding also, again, not the expert, just my basic understanding is this alternator, and if you get one of these self-exciting one-wire alternators, they also have basically a set of diodes and relays in them, built into them, that is a charge controller of sorts, senses what the battery can handle, where the voltage is and what the battery is at as state of charge, and then it self-excites by basically routing some battery power back into the coil, and depending on the amount of power that goes into the coil, that adjusts the amount of power coming out to charge the battery. And it does that automatically, internally. It's got that built into the alternator. So in this case, that's what it looked like it was doing. And I definitely noticed when I had the batteries were at a higher level of charge and I connected the alternator, you could hear it bog down a little bit because that's what naturally happens is as soon as it starts pulling, it increases the magnetic force, causes that engine to work harder to spin it. When I did it at a battery was really low and I connected it, it pulled that bad boy. I didn't have it full throttle. The first time I did it, I didn't have that engine at full throttle, and I connected the battery lead and it killed the engine because the draw was much higher than it was the previous time when the battery was more full. So I had to go back out, start that engine back up, throttle it all the way up to full throttle, and then I was able to connect it. And I heard it bog down. It was really sucking up some juice, but because I had it at full throttle, it was able to continue to charge the battery up, and I could clearly see the battery going up from running that. The problem is I don't have an amp meter, right? If I had a good amp meter, I've got a little multimeter, but it's got a 10 amp fuse, and I'm pretty sure I blew that 10 amp fuse because I'm pushing more than 10 amps into those batteries. And so I need an amp meter that I can put in line between the alternator and the batteries. And then I'd be able to actually see how many amps and how many volts. Because right now I can only look at the volts, except for when I was going through the charge controller. When it was going through the charge controller, it was showing me on the charge controller the volts and amps. But like I said, I don't know. It's an MPPT charge controller, and it's supposed to basically use it's maximum power point technology, or maximum power point tracking is what MPPT is. So it's looking at the incoming power. Basically it says, okay, I have this much voltage and amperage, which equals a certain number of watts. The watts don't change, right? The watts are the same no matter if that source is coming in, it's a certain number of watts. However, you can increase the voltage and that lowers the amperage, but it still equals the same number of watts because it's volts times amps equals watts. Or you could lower the voltage and increase the amperage, vice versa, in order to maximize what you're pushing through it, right? Again, that's what I believe is happening. I'm sure there's a lot more technical terminology and things that are out there. Feel free, if you know all this great stuff, to put it in your, in the comments or whatever. But this is just my basic understanding of how this works, right? Volts, amps equals watts. It adjusts voltage or amperage in order to maximize the amount of watts that are coming in. So, in theory, by connecting that alternator through that charge controller, what it was showing me would have been the best charge that would have been able to provide for the batteries. However, my concern, or in my mind, what I'm thinking is, because the alternator has its own little controller built into it, that it may have been not necessarily canceling each other out, but if they're not really programmed together, right? They're not on the same page. They're not working the same way. And so if the charge controller is trying to reduce, I don't know, maybe reduce the voltage and bring up the amperage, then the alternator sees that as a fuller battery, maybe, and then doesn't push out as much juice. I don't know. But that's why I would like to have a amp meter to connect that in line, so that I could actually see, when it's directly connected to the batteries, how many amps and how many volts, and then I can see what my wattage is that's coming out of that alternator. Because I don't want to lie, again, I'm just guessing on this. It's a 24 volt, and I believe it's a 70 amp max on that alternator. So theoretically, if it's connected directly to the batteries, and the batteries can handle up to 100 amps at a time, then when that alternator is spinning at 6,000 RPMs, maximum, output, it should be pushing out close to that 70 amps. And if that's the case, then it should be charging those batteries pretty quickly, which it looks like it is. But it's difficult with these batteries to really know what your actual state of charge is. And again, I'm not the guru's guru. I don't know all the ins and outs. I know there's equipment that I could get, which I don't have, and I'm probably never going to get, that you can use to be more accurate as far as reading your state of charge on your batteries and all that kind of stuff. I'm not as concerned with the specifics on those as I am with putting as much juice into them as I can. And my understanding also is that the alternator will adjust, so it should not overcharge the batteries. Just like in your car. If your battery is completely full in your car and you're driving down the highway, right, and that bad boy is spinning at maximum RPMs, it's not going to blow up your battery. It senses the battery state of charge, and it automatically adjusts the charge controller internally on that alternator. If you have the like 3-wire or different style alternator, then there's a external voltage regulator that is with that, and that does it. But either way, that I don't think is a concern, to be able to worry about the battery getting overcharged with the alternator. Now, the idea, and like I said, proof of concept, is, given that it looks like it does produce a good voltage to charge those batteries, if I wanted to fully charge those batteries, I would have to run that thing for like 8 hours straight, full throttle. The little motor only has like a 1-gallon fuel tank on it. And I literally ran it the other day, the full tank of gas. I just ran it until it ran out of gas. And it charged up the batteries quite a bit. I mean, we haven't had good sunshine in here for the last 3 days. We had a little bit of sun breaks here and there on Friday afternoon. It is now Monday. Pretty much Saturday and Sunday was pretty much just cloudy all day. And so I ran that alternator on Saturday, and it brought us up to a decent state of charge. But again, I ran it, and I think it ran full throttle with that 1 gallon of gas. And I hate to say it, but I didn't really pay that close of attention to the time. But it definitely was running for probably it was over an hour. I know that much. I don't know how long it was running, honestly. But if I wanted to just keep that thing running for 8 hours straight, it would probably charge that battery bank completely. I'd have to do some math, and also not knowing exactly what the amperage is that it's pushing out, I couldn't say for sure, but I feel like that would definitely do the job. And with that being said, if I used that alternator on my water wheel for hydroelectric and it just ran full time all day long, that would keep my batteries charged completely because that creek flows 24/7. So if I had that set up and I geared it down from 100 RPM at the wheel itself, which is actually moving not super fast. It's just a steady rotation that's making in the creek. Then if I stepped it, from a 10 to 1, so if I had a 10-inch or larger gear at the wheel, at the water wheel, and that was going to a 1-inch gear, right? Then that would give me a 1000 RPM at that 1-inch gear. And then if I step that up and that was on a single shaft and the other gear on that same shaft was a 6-inch gear, and that stepped down to a 1-inch at the alternator, then that's going to do a 6 to 1, which would go from 100 to 1000, and then 1000 to 6000, and that would have that alternator rotating at 6000 RPMs while the water wheel is going at about 100 RPMs. Again, I don't know if that's going to work or not. I know there's ways of measuring your flow rate and your head and all that kind of stuff, but to be honest with you, I'm not going to do that. The reason I'm not going to do that is because it doesn't matter. It's literally going to just be experimentation with my creek that I have, because I can't change the flow of that creek. I can't go in there and dam the creek. I can't go in there and do any major excavations or changes to the creek because it splits our property line, and there's brook trout, there's naturally wildlife and other things that are in that creek. And so I don't want to impact that, as I want as little impact on that as possible. So that's why I'm thinking that an undershot water wheel set in a good position where there's a little bit of a bottleneck on the creek already, it increases the velocity of the water right there. And if I can just do that without having to do anything else, and I can get that wheel to spin with a good amount of force right around 100 RPMs, and then hook everything else up, that's what I would like to be able to do. So that is what's going on with that. And coming soon, we will have our new system, the upgraded system. And that upgraded system is going to be a 48 volt system, not a 24 volt system. And you might be wondering, well, if you're upgrading to a 48 volt system, why are you putting all this effort into making a water wheel or setting up this thing and it's just going to get swapped out? That's because this system that's in the house right now is going to end up going into the little cabin next door that I'll be working as a workshop, and it'll still be getting used, and it'll still be very, very good to have. And if I can do that with the water wheel, I can get a different alternator slash generator that puts out the 48 volts instead of 24 volts. And I can connect that to our larger system if I get the infrastructure built that can rotate that wheel and has enough water pressure or force behind it, I can swap that out with a different generator alternator setup that pushes out the voltage that we need. So it's not going to be a waste. It's, again, building on the systems that we have and growing the systems that we have and learning from those things, because this has been a learning curve right here. Summertime, even in the fall, we had plenty of sunshiny days, and that system more than did what we needed it to do. Now, we run the generator for showers the last couple days because the water pump that we have does a great job, charges up the tank, gives us plenty of water, but it just takes a lot of power. For the small system that we have, it takes too much power. And I'll do a whole thing about what I'm doing to fix that problem. So that's something else that we're going to be doing. We ordered the larger tank, and when that comes in, I'll do a video on that to show what we do and how it works. So hope you like what you see here. Hope it was a nice little update, a little bit of information on what I'm doing and what my crazy brain uses for thought process. And I will let you know what happens with our new system when it shows up. It's coming, and it's in the mail. So more to come. I hope you enjoyed this, and if you liked it, then that's awesome. If you didn't like it, oh well. And Dave, I promise there is a video coming about the water wheel and the hydroelectric. It will be coming. I'm not going to be doing it anytime soon, though, unfortunately. It'll be here eventually, though. So thanks again for coming and checking it out, and we'll see you guys later.